This video is about part 2 of solving a system using substitution. So before we start solving using substitution, we need to talk about another step that we're going to add in. So this time, instead of just having a y equals or an x equals, we have to isolate one of them. So when we're trying to isolate a variable, we want to figure out which variable has a coefficient of 1. So in number 1, we would solve for x by moving the 3y to the other side. And then we would have our isolated variable. So if I subtract 3y from both sides, now this looks like an equation that we would have used yesterday. In number 2, the y in the second equation has a coefficient of 1. So when I subtract 4x from both sides, this would have looked like an equation we would have used yesterday. So we're just adding in one more step of having to get a variable by itself first. So in the substitution method, the first step is to solve for one of your variables, either get x or y by itself, and then the steps that we did yesterday. So we're going to substitute and solve, and then substitute the number and solve again. So in number 3, we have a variable already by itself because we have 2x minus 2y equals negative 25 and y equals 3x. So we can box 3x and put that in for y. So when we rewrite this, we have x minus 2 parentheses 3x equals negative 25. So when we multiply here, we get x minus 6x equals negative 25. Combine our x's, negative 5x equals negative 25. We divide by negative 5. X is 5. But we're not done yet because we have to solve for y. So we're going to put 5 in place of x. Y equals 3 times 5. So y is 15. Our ordered pair would be 5, 15. 2, we have x plus 5y equals 4. And 2x plus 10y equals 28. So again, in number 4, this x has a coefficient of 1. So we want to get that x by itself, so we need to move the y to the other side. So we're going to subtract 5y from both sides, and we get x equals 4 minus 5y. So now we're going to box what x is equal to, and we're going to substitute for x in the second equation. So we have 2 times 4 minus 5y plus 10y equals 28. So when I distribute, I get 8 minus 10y plus 10y equals 28. Combine like terms, negative 10y and positive 10y becomes 0, so we just have 8 equals 28. So this is one of our special cases. Remember that 8 does not equal 28, so this is an example of a no solution. So remember when your variables cancel out, that's a no solution, and then we just stop. We don't have to go back and get the other variable. It's one of our special cases. Number 5, we have 2x plus y equals 20, and negative 3x minus 3y equals negative 60. So in this case, the variable that has a coefficient of 1 is the y in the first equation. So we want to get that y by itself, so we're going to subtract 2x from both sides, and we get y equals 20 minus 2x. So now I'm going to take what y is equal to, and I'm going to substitute for y in the other equation. So I get negative 6x minus 3, parenthesis 20 minus 2y equals negative 60. So when I distribute, I get negative 6x minus 60 plus 6x equals negative 60. So when I combine the x's, I get 0, and I'm left with negative 60 equals negative 60. This is a true statement, so this is our other special case. So remember, when this is true, we're going to have infinitely many solutions. Let's look at one more problem before we get into our word prompts. So in number 6, we have x plus y equals 7 and 5x minus 2y equals 21. When both of them have a coefficient of 1, so in the first problem like x and y, it doesn't matter which variable you solve for. So I'm going to solve for y, so I'm going to subtract x from both sides. Y equals 7 minus x. So I'm going to substitute what y is equal to into the other equation for y. So I have 5x minus 2, parentheses 7 minus x equals 21. So in order to solve, I need to distribute. So 5x minus 14 plus 2x equals 21. I can combine my x-like terms, so I get 7x minus 14 equals 21. I can add 14 to both sides, so 7x equals 35. And I can divide by 7, so x is 5. Once you know x is 5, go back and substitute. So if I know x is 5, I'm going to put that into the first equation to get y. So I have 5 plus y equals 7. I can subtract 5 from both sides, so y is 2. So my final answer would be 5, 2. Now let's look at some word problems. Number 7, the local movie theater charges $5 for students and $8 for general admission tickets. If 280 tickets were sold on Friday afternoon for a total of $1,691, how many of each ticket were sold? So the first thing we need to do is we need to identify our variables. So there's two types of tickets that we have being sold. We have S for student, and we have G for general admission. Now, there's two totals they gave us, how many tickets we have and the total money. So to get the total number of tickets, we're just going to add the people together. So S plus G equals 280. And then we're going to do the same thing with money to get 1,691. So there's $5 per student, so 5S plus $8 for general admission, 8G equals 1,691. So now I need to get a variable by itself. So I both have S and G here. I'm going to subtract G from both sides to get S by itself. So S equals 280 minus G. Now that I have S by itself, I can box what S is equal to and box S in the other equation. So now I'm going to substitute. I'm replacing S with 280 minus G. So I get 5 times 280 minus G plus 8G equals 1,691. So when I distribute, I get 1,400 minus 5G plus 8G equals 1,691. When I combine like terms, I get 1,400 plus 3G equals 1,691. I can subtract 1,400 from both sides, so I get 3G equals 291. And when I divide by 3, G is 97. Now that I know G is 97, I can substitute. I'm going to use the first equation because there's less exponents and less work to have to do. So I'm going to substitute that in for G. So I get S plus 97 equals 280. And when I subtract 97 from both sides, I get S is 183. So remember with ordered pair, go in alphabetical order if they're not X, Y. So we have 97 comma 183. We also need to write a sentence because it's a word problem. So there were 97 general admission tickets and 183 student tickets sold. Let's look at one more word problem. So in number 8, the softball season is around the corner and the coach needs to order some new equipment for some of the players. The coach ordered a total of 13 items for a total of $2,675. The coach ordered gloves for $63 and bats for $295. How many gloves and bats did the coach order? So when we need our variables here, we're looking for gloves and bats that were ordered. So we're going to say G is going to be our glove and B is going to be our bat. So there's two totals. There's 13 items and the total cost. So when we add the gloves plus the bats, they should equal 13. And then we need to include our money. So 63 times G plus 295 times B equals 2,675. So now I need to get one of the variables by itself. So this time I'm going to get G by itself. So I'm going to subtract B from both sides. So I get G equals 13 minus B. So I can box what G is equal to, and I can box G in my other equation. So I get 63 times 13 minus B plus 295B equals 2,675. So when I distribute the 63, I get 819 minus 63B plus 295B equals 2,675. So I can combine those B terms, and when I combine those, I get 819 plus 232 equals 2,675. I can subtract 819 from both sides, and I get 232B equals 1,856. When I divide by 232, I got 8B. So I can substitute 8 back in for B, so I get G plus 8 equals 13, which means that G is 5. So remember, when we write our ordered pair, we're doing alphabetical order, so we have 8, 5, and we also have to say what this means. So the coach ordered 8 bats and 5 gloves. So in this problem, the Johnson family is going on a group outing to a minor league baseball game. There are a total of 12 people going, and the family is spending $140 on tickets. The tickets for children cost $7. The tickets for adults cost $15. How many children and adults went to the game? So first thing we need to do is identify our variables. So we are going to have A for adult tickets and C for children tickets. So we know that 12 people went to the game, so we would have A plus C equals 12. And then we know a child's ticket is 6 and an adult ticket is 15, and they spent $140. So we have 15A plus 7C is equal to 140. So in order to solve this problem then, we need to get one of the variables by itself first. So in the first equation, A plus C equals 12, I'm going to subtract C from both sides, so we get A equals 12 minus C. Now we can take 12 minus C and we can substitute in for A. So we get 15 times 12 minus C plus 7C equals 140. When we multiply, we get 180 minus 15C plus 7C equals 140. We can combine the C's, so 80 minus 8C is equal to 140. We can subtract 180 from both sides, so 8C is equal to negative 40. When we divide, C is 5. So we know that they have 5 children's tickets. We can put that in place of C then and get A. So we have A plus 5 equals 12, which means that A is 7. So for our final answer here, we have the ordered pair 7, 5. So they bought 7 adult tickets and 5 children tickets.